I'm ready to get started. You guys ready? Let's go. So today I'm going to talk to you all about Spacechain. And Spacechain is a method of doing a sidechain that was invented by an online friend of mine, Ruben Thompson. I also am presenting how it works. I'm going to show you a little demo of it. So what we're going to cover, we're going to cover the two main parts of what a spacechain is, which is two things that constitute a spacechain. It is a sidechain that has blind merge mining. I'll tell you what that is. And it has something called a one-way peg. So those are the two parts that combine together to make a spacechain. After I go over what those are, then I'm going to go over how to do blind merge mining, because that's what I think is the really cool part of spacechains. Then we're going to go over some use cases, things that you can use spacechains for. And lastly, we're going to go over the difference between a one-way price peg and a two-way price peg. And I'm going to give examples of what those are. So some of these terms might be unfamiliar to you right now, but guess what? That's what the presentation's for. I'm going to cover all those things. Then lastly, I'm going to do a demo, and I'm going to actually show you how to create a space chain. So let's get started. Everyone ready? I will be occasionally checking in for questions. So throughout the thing, feel free to post questions in the chat, in the Zoom chat, and I will periodically check in to see if anybody has any questions. Okay, so let's talk about merge mining. Merge mining is something that was invented a very long time ago by Satoshi Nakamoto, back when he created Bitcoin in that first year between 2009 and 2010. There was a lot of innovation and development, and one of the things that was quickly discovered was that blockchains need to know the order of the blocks that are on that chain. That's really important because, like, if I'm supposed to pay Alice, but that block came before the one where, Alice paid someone else, everything gets all screwed up. It's like, how could Alice send money that she didn't have yet? You need to know the order of when people got their money in order to have a good blockchain. And in order to do that, you need to know the order of the blocks on that blockchain. So Bitcoin, solves this with proof of work, and it allows us to come to consensus on the order of blocks in Bitcoin. But with merge mining, this is a proposal by Satoshi that would allow two different blockchains to share proof of work, and thus you'd be able to follow the order of transactions just by knowing one of those blockchains. So the way this works, you can see over on the sidebar here, I've got a person mining, and he has a Bitcoin miner as his head because he's a Bitcoin miner, and he's created a block here. So it's got a little hash up there at the top, which I'm representing as, the hexadecimal characters A, B, A, B, A, B, etc. And that's the Merkle root of Merkle tree of transactions. So there's a lot of words there, but basically you take a whole bunch of transactions, you hash them, and you put that hash at the top of your block. It's called the block header. And then if some people can prove that their transaction is in this block by recreating that hash using and proving that their transaction is in it. So this little hash there right at the top is really important. It basically contains a fingerprint of all the transactions that are in that block. Well, merge mining uses the fact that there are a bunch of fields in a block where miners can add data, and so what if we have a second block, a second block of a different chain, totally different blockchain, that's being mined at the exact same time. And instead of doing proof of work on that block as well, what we do is we just take all the transactions on that other block, we hash them, and we stick that hash into our Bitcoin block, into one of those fields that miners can add text into. And if you do that, then as the miners mine the Bitcoin block, as they find a proof of work that's valid for all of the data in that block, it's also going to be valid for this other block. It's also going to be valid for that set of transactions that hashes to, CD, 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 or whatever the hash happens to be. And so that allows you to have one set of miners doing one set of proof of work on Bitcoin, but that proof of work is also valid for a totally separate blockchain. Yeah, it allows you to do this thing where Bitcoin blocks contain two hashes corresponding to two sets of transactions. And I actually have an example here because we've been doing merge mining in Bitcoin for a very long time. So here's a block 784,800 was mined in Bitcoin about 3 months ago. And if you take a look at the data inside the block, we've got a couple of different fields here called op returns. These are created in the Coinbase transaction, which the miner is in control of. He controls what's in this thing. And so if we take a look at the details section of this little transaction here, let's go into details. You can see that there are 3 op returns. There's this one, there's this one, and there's this one. And this one is special. This one starts the op return data, this text field that exists in Bitcoin starts with the term RSK block. And then it has this 32-byte hash right after it, So what is an RSK block? Well, RSK is another blockchain that is merge mined with Bitcoin. And they do this every time there's a block on this sidechain. Well, not every time, but every certain number of blocks on this sidechain, they take a hash of all the transactions in that block. And here's that hash, and they put it in Bitcoin with a little header that says this block came from RSK. So now when the Bitcoin miner finds this block, when he mines it, he puts that transaction in his block, and he finds a hash for it that starts with this many leading zeros, all of those leading zeros. That took a lot of work for him to find all that, and that work overflows to this other blockchain. It's also valid for any piece of data that you put into the blockchain. Is proved that the proof of work proves that you did a lot of work to find a hash that is valid for that piece of data. So merge mining allows us to have other blockchains that are merge mined with Bitcoin, that Bitcoin miners can just mine on Bitcoin, but they can include data from other blockchains in order to validate that the order of blocks and the order of transactions on that alternative chain. So that's something called merge mining. And Satoshi invented it. It allows us to do this cool thing where Bitcoin miners can mine two blockchains at once without doing any extra work. But there are a couple of problems with merge mining. One of them is that regular merge mining needs special mining software. Miners have to actually construct blocks on this sidechain. It's not a lot of work, but it is some extra software they have to do to construct, to aggregate transactions on this other blockchain and then hash them basically. And then once they do that, they can include that hash in Bitcoin and just work on Bitcoin. But they need to run special mining software for that. And so anyone who wants to create a merge mined sidechain, a merge mined blockchain, you kind of have to convince miners to run your software. Say, okay, I've made a thing where you can do this. And that's kind of hard. That results in a bootstrapping problem. Rootstock is the one I showed you in the previous example. They've been doing this for 6 years, merge mining with Bitcoin, and they've only got about 50% of Bitcoin miners running their software. So it's kind of hard to get miners to run this stuff. That miners just, they're not always interested in running whatever software someone presents to them. And the other thing is it helps proliferate altcoins, because when you create these transactions on this alternative blockchain, those need to pay fees with something. And this other blockchain is not a Bitcoin blockchain, so it doesn't have Bitcoin on it. And in this, you have to create some alternative token to pay fees to make those transactions and to pay miners for doing this for you. So the two problems with merge mining are it needs special software and it helps proliferate altcoins. And the reason I'm bringing all this up is because Spacechains have a solution for this. They have a solution for these problems that makes merge mining better. So the solution is called blind merge mining. Blind merge mining was invented by, the great genius and super smart guy, Paul Stork, who is presenting right after me. He's presenting Drive Chains immediately after this presentation. So if you want to learn more about blind merge mining, he's the guy to go to. So with blind merge mining, miners don't know that they're actually that they're doing this. That they don't know that they're mining an alternative blockchain as well. And it's a pretty cool trick that we use to to make them do work on another blockchain without actually knowing they're doing it. So they don't need to know what's happening, which is why we put the little sunglasses on them to indicate, that they're blind. They do still make money off of it. They actually gain transaction fees from it. We can do it without we can do it with a soft fork. Paul Stork will tell you in the next presentation about BIP 301, which is his invention for doing blind merge mining. It's a soft fork that would enable, allow us to do this efficiently on Bitcoin. And there are a couple of other soft forks that let us do this. SIGHASH no input has been proposed for Bitcoin for a long time. It would help out with Lightning, but it would also let us do efficient blind merge mining. OpCTV, also called check template verify, would let us do this. There's a recent OpVault proposal that would work too. All these things enable efficient blind merge mining. However, there is an inefficient way we can do it today. You can actually do blind merge mining today, and I'm going to show you that in my demo. So right here, I'm just describing what blind merge mining is and what its benefits are. In 2 more slides, I'm going to tell you how it's done, and then I'm going to show you with the demo. But first, I want to tell you what the other part of Spacechains are. So blind merge mining fixes the problems with regular merge mining. It makes it so that you don't have the bootstrapping problem, and you can actually use Bitcoin to do blind merge mining instead of creating an altcoin, which is cool. But I'm going to tell you more about how it works in a minute. First, I'm going to tell you about the other part of Spacechain, which is the one-way peg. And this part of Spacechain is, in my opinion, stupid. I don't really like the one-way peg, but let's talk about what it is. So with traditional sidechains, one of the things people want to do with them is they want to have a sidechain that has some features, like maybe a really private sidechain, or maybe a sidechain with smart contracting features as powerful as Ethereum's or like Liquid. They want to do these sidechains that have expressive functionality or better privacy or some feature that people want. But what they want to do is they don't want to create an altcoin. They want to do this thing where you take your Bitcoins, you put them on the sidechain, you use it for a while, maybe make some money, maybe lose some money. But when you're done, you take your remaining Bitcoins and put them back on regular Bitcoin and have assurances that you're going to have the same amount of money, or minus any losses you incurred once you go back to Bitcoin. So this property is called, in Bitcoin, the traditional term for this is called a two-way peg. You peg into a blockchain, into a sidechain by putting your Bitcoins onto it, and you peg out of a blockchain by taking your Bitcoins off of it. So that's called a two-way peg, where you have the ability to go in and out of a sidechain without like slippage or without losing any Bitcoins. It turns out that's hard to achieve in a robust way, and in a way that satisfies Bitcoiners' thoughts that like they don't want to get robbed. Two-way pegs are hard. And so Ruben proposed, let's do a one-way peg instead. And this idea here is you can put your Bitcoins onto the sidechain, but you can never take them out, except by selling them. You could sell them to people and then take them out that way. But yeah, there's no like protocol way of getting them out of the sidechain. Because getting them on is actually pretty easy. He shows here how you can do it by just destroying them. So he proposes that you use Bitcoin's op return function. When you create an op return, you create one of these text fields in Bitcoin. You have the option of sending Bitcoins to it. And if you do, those Bitcoins are never spendable. You sent them to a piece of text that is not a script. There's no way to like execute that and get them out. It's just they're just stuck in a piece of text forever. And so he proposed, well, let's do this. Let's actually say, I'm going to take 5 Bitcoins, and if I want to put them onto a sidechain, I'm going to send them to an op return. I'm going to send them to just a piece of text. And then that is going to, I'm going to put a proof of that transaction on the sidechain. And I say, look, here's my proof that I burned, 5 Bitcoins. And then the sidechain would like credit you. It would validate that happened on Bitcoin, and then credit you on the sidechain with a similar amount of sidechain coins. And that way there would be always this way to get onto the sidechain. You could always take your Bitcoins and put them on by destroying them on Bitcoin, and then getting a credit for them on the sidechain, but you can't get them off. There's no way to go back the other way. And he thinks that if we did this, there would be some beneficial properties. For example, it would put a ceiling on their price. It would be a little bit better than making an altcoin, because an altcoin's value floats in reference to Bitcoin. It can go above it, it can go below it. But if you create the sidechain tokens by burning Bitcoin, the value of those burned Bitcoins can never go above the value of real Bitcoins. This is illustrated by this graphic here. Let's say that happened. Someone burned some Bitcoins. They created a space coin with it. They burned 5 of their Bitcoins. They created 5 space coins, and now they want to sell one of them. And so they go up to Mr. Blue Man here and they say, hey, I have a space coin here that I created by burning a Bitcoin, and I would like to sell it to you for more than a Bitcoin, for 1.2 in this case. Well, the blue guy is not going to take that deal. He's going to be like, well, that's stupid. I can just make my own. If I've got 1.2 Bitcoins and I definitely got 1 Bitcoin, then I can just burn that to get my own, sidechain Bitcoin. So the fact that you can create your own makes it so that a one-way peg makes it so that the price of the sidechain token can never realistically go above the price of Bitcoin, which puts a cap on it, and it reduces the amount of speculative stuff you can do with that token. So that's kind of a cool property. The one-way price peg means that there's a cap on the price of this token, and it's less like an altcoin. So no one will buy space coins if creating them is cheaper. So there's a price ceiling on them, and that's kind of an interesting property of the one-way peg. The real negative of it is that, well, you have to destroy Bitcoins. Like the way you do this thing is by taking Bitcoin, sending them to a piece of text, and you can never have those Bitcoins again. You just get a corresponding amount of sidechain tokens. And if no one uses that sidechain, if there's no demand for it, then you're just screwed. You just lost money, and there's no way to fix that. So I don't like the one-way price peg, but it is a part of Spacechains, and actually it's an optional part. You can make them without them. But the one I'm going to show you later does have a one-way price peg, even though I think it's stupid and I don't recommend doing that part. Do make Spacechains, but make them without this silly one-way price peg. Okay, so I've said a lot of words so far, and I'm going to go check and see if there are any questions at this point. I've got more slides to come, but let's just go see if there are any questions. So I'll go to the chat section and let's see. We've got some questions. Very grateful to be present with you all today. Yeah, me too. What is the difference like running 2 mining software operating system layer? I'm not quite clear in what your question is. I think the thing that comes to mind is, are you asking, is it like hard? Is it hard for your computer to run 2 mining software? It probably would be, but with this, you're not running 2 mining software. You're just mining Bitcoin. The only thing you're doing with the sidechain is you're aggregating transactions and then hashing them, which is a much simpler operation. You're just listening for data that comes in and gets added to a database that takes that doesn't take a significant amount of compute, and then you hash them, and that also doesn't take a significant amount of computation. So it's very easy to run merge mining, or to do merge mining. You listen for transactions and then you hash them. So at the operating system layer, it's pretty easy to do. Could you stake them for 10 years instead of destroying them or something? Yeah, there have been proposals for doing something like you put Bitcoins into a address that allows miners to spend them, allows a miner to take them after 10 years. And you could do that instead of burning them. Do they have the same value? Like you've created, if you do that, then they're going to have less value than a real Bitcoin would, because they can be essentially double spent after 10 years. If those coins still exist on the sidechain, now they're off it again. Like they're in 2 places. They're on the sidechain and they're on Bitcoin. And so the risk of that happening would mean that they don't have the same value as a regular Bitcoin, because they're not as scarce. Because they can be in 2 places at once, even though it'll take 10 years for that to happen. That the fact that they will eventually possibly be in 2 places at once would mean their value would be discounted. Or at least that's my economic theory. You could try it out. Make a space chain that locks them up for 10 years instead, and see if that works. That'd be cool experiment. If some chains have only 50% of support for miners, does that mean at any given time the data gets outvoted? So yes, I think the answer is yes. So what can happen on one of these, on merge mine sidechains, is that you take a hash of a sidechain block, you put it into Bitcoin, For a few blocks in Bitcoin, there's no blocks built on top of that. And so it's actually pretty easy for another miner to come along and outvote you, to like make an alternative hash and build on top of his own, and thus eliminate your hash from the blockchain. So that can happen if all the miners aren't doing it. Then yeah, you can get the situation where like you have block reorgs on the sidechain that didn't even involve doing anything weird on Bitcoin. Blind merge mining actually fixes that too, because as long as miners are including all transactions in a blind merge mining scenario, they don't know what they're mining. They don't know that they're mining a sidechain, and so you can avoid that problem. But I will get to more about how merge mining works in the next slide. If Spacecoins are successful, there will be less supply. How successful was Spacecoin? Well, there haven't been any on mainnet done. There's only 2 implementations of a space chain. There's one by me and one by a friend of mine called Fiat Jaff, and both of ours are on Bitcoin's test networks. So they're not successful at all. They're just test things that we made to prove how space chains work. If they are successful, there will be less supply. Well, probably not. If they're successful, that means there's demand for them. And since anyone can create them by just destroying Bitcoins, there would probably be as much supply as there is demand for them, because you can just, if there's people who are wanting to pay for these things, there will be people creating them so they can meet that demand. So I'm going to go with this question here: is ASIC mining still profitable? Looks like Andy answered that, so thank you, Andy. And time lock instead of burn, I talked about that. I'm going to stop here then and go back to the presentation, and then I'll come back for more questions after a bit. Sound good? Let's keep going. Okay, so minimize you, back to the slideshow. So that's the one-way price peg. Now let's talk about how blind merge mining is actually done without a soft fork. Okay, so the way we do regular merge mining is that miners put text in a block. They take a hash and they put it into Bitcoin. Well, there's no reason that hash actually has to be created by a Bitcoin miner. Bitcoin has fields where anyone can add text to a block. Excuse me. So anyone can create an op return in Bitcoin. Anyone can create one of these text fields and put text in it. So all we really need is a list of those. Like we need a way to track, this one came first, this one came second, this one came third, and follow them. Like all a blockchain is a linked list. And here we're just linking to a hash. And then you actually go get the full block from the sidechain network. So all we really need is a linked list of op returns, or you can do this with witness data like ordinals do. But we can do that. Like we don't need a soft fork for that. So I'm going to show you two blocks that are already doing this. This is a block on Bitcoin's Signet. Up here you can see the term. You can see the term Signet right there. That's one of Bitcoin's test networks called Signet. And you can see a block was created right here, and there's a transaction in this block right here that has an op return. This transaction was not created by a miner. This is just an ordinary, fee-paying transaction. You can tell it wasn't created by a miner because it pays fees. Miners don't need to pay fees because they mine the block. But this is created by a regular user. It pays a fee, and it uses an op return, which let's take a look at that op return. And the op return is just a 32 byte string right there. So that is the hash of the block of the sidechain that somebody put into Bitcoin. And you can make a linked list out of these things by just repeatedly using the same Bitcoin address to do this. So let's see. He is spending from. He is putting this money into which address is this? PHC9, I think, is the one. And so if we look at that PHC9 address, yeah, it's got all these transactions coming from it, and they keep on spending out of it and then putting the money back in. They spend out of it and then spends out of PHC9 and puts the money back into PHC9. So this person keeps, whoever's creating this sidechain, they keep on spending from the same address back into itself. And every time they create an op return that has the hash of their block. So this by reusing an address, you can create a linked list. You can always just say, I know that I just need to watch this one address, and every time there's a transaction, it's going to create an op return that's going to create a text field that has the hash of a sidechain block. So that's a linked list. That's a linked list of hashes that you can just follow on Bitcoin. And thus anyone can do this. Anyone can create one of these things. So here's the one that I created on Bitcoin's Testnet network. This is a block, and within it, there's a transaction here. And this one is spends from the address QRDO right there and into the address QRDO. And this one doesn't use op returns to publish the data, but it rather uses witness data. So there's a 32-byte witness data right there that corresponds to the hash of the sidechain block. And if you just keep on following this, you go back into that address, it's just got, one of these things after another. You just keep on taking money from the same address and putting it back in, and every time, it's just recreating the same address and adding more money into it and adding another piece of witness data. So what we're doing here is we're creating a linked list of text fields that contain hashes, and those are where the sidechain blocks are. So that's blind merge mining. Miners, they just look at these transactions and they just say, okay, here's a transaction that's adding a text field to Bitcoin, pretty standard, I'm just going to mine that. Miners don't know that these things are hashes of sidechain blocks, unless they're like also paying attention to the sidechain. They're just treating these as regular transactions. And so as long as you can get a regular transaction into Bitcoin, you can do blind merge mining. You can have a linked list of text fields that correspond to sidechain blocks, and thus Bitcoin, you're using Bitcoin to create order on this sidechain. You're using the fact that Bitcoin's proof of work makes it hard to reorg Bitcoin to also make it hard to reorg the sidechain. And this makes it so that 100% of miners are mining your sidechain. They just don't know it, which is pretty cool. It's like an improvement on regular merge mining. So who produces these blocks? Well, ordinarily, a Bitcoin transaction, a Bitcoin address can only be spent from by one person. Usually a Bitcoin address is it's basically a public key. You send money to it, and then only the person who has the private key to that address can spend it. That's pretty standard. Well, that's actually not a good thing with blind merge mining. It's not good if you just send money to a Bitcoin address and then the guy who has that private key is the only one who can spend it, because that would mean if he goes away, your sidechain dies. Like no one can reconstitute or keep this linked list going. So that's a negative about them, but there is a fix for it. Bitcoin has this function in it called anyone can spend. You can create a Bitcoin address that doesn't have a private key, a Bitcoin address that doesn't have even a public key. And anyone can deposit money into this address, but also anyone can spend it. And if we use this property, we can make it so that even if the original guy who started a sidechain dies, well, anyone can still keep this thing going. You just have to keep depositing money into that address, and then to pay for fees, and then re-spend it to keep the linked list going. That allows anyone to mine on this sidechain. So that's pretty cool. You can use anyone can spend for that. But it comes with a problem, which is, anyone can spend. So I've got a picture of a little guy over here, and he sees that somebody put some money into this, address that's designed for mining a sidechain. But he's like, hey, anyone can spend that, and I'm anyone. Why don't I just take that money and run off with it? So with sidechain, with merge mine sidechains, this isn't actually that big of a deal. First of all, it's a tiny amount of money. It's like you only need enough in there to pay for a transaction fee on Bitcoin. So it shouldn't be very much money. And in fact, it actually should be outbid. It should be the amount of money that's in there should not be, the people who are mining the sidechain should actually pay more than that in order to mine their blocks, because they're getting fees on the sidechain, and they will actually bid amongst each other to be the first one to move money from this Bitcoin address and create the next block. That way they get sidechain fees. And so they're willing to put, if there's like $2,000 worth of fees on the sidechain, they're going to be bidding up to $2,000 to create the next block. And all that money is going to fees on Bitcoin. So if somebody's trying to steal the little 546 sat output, he has to bid like $2,000 to do that, which is unlikely to happen. But even if he does, it's not a big deal, because you can just detect somebody stole the output, and then the next, you just skip. It just means you skipped a block. You skipped a block and someone puts money into it, and you restart. You just keep going. You just build off of the last block that wasn't stolen from. So yeah, using anyone can spend, it does have the problem where there can be one block outages where someone might spend a lot of money to take the 546 sats that are in this sidechain address. It's not a big deal. You can just easily recover, but it is a slight problem. This means that there's not a one-to-one mapping between sidechain blocks and Bitcoin blocks. There might be occasionally some that are skipped. So there's a couple of proposals to fix that. Like I mentioned previously, you can use any of those soft forks to do blind merge mining. You can use BIP 301, which you'll learn about right after this. And there's something called the prepaid model, which I want to show you how the prepaid model works. But I want to give a little bit more detail about how the anyone can spend model works. This is the one that I used when I made my my sidechain, my Spacechain. So the anyone can spend model works like this. You put a dust amount of sats in an anyone can spend address, which I affectionately call the AXA, because anyone can spend address. Then you just look for a linked list of transactions that contain a hash and recreate that output. You're just taking money from that address, putting it back into it. All that money is there for is to pay fees, so it doesn't need to be very much, like $1 or something. You just have enough in there to pay for fees. And every time that there's money in there, you create a text field. Anytime you take money out of it or put money into it, you create a text field that has a hash of a sidechain block. If somebody steals the dollar, if somebody steals that little dollar, no big deal. That just means the linked list suddenly doesn't point to it doesn't point to the same address that the money came out of. It's going to the thief's address. He wanted that dollar. So if that happens, you just detect that, well, somebody didn't put the money right back into the same address again. They took it. So we'll just start scanning the blockchain after that point for the first person to put money back into the anyone can spend address. And then we'll move from there. So it's pretty easy to recover from. You just put $1 back into that address and keep going. And miners of the sidechain are incentivized to do this because they're getting sidechain fees. They're getting thousands of dollars on mining the sidechain. So they can just easily afford to put $1 in there and keep earning thousands of dollars every block. So that's nice, and you don't really have to worry about thefts happening very often anyway, because the thief would have to pay like $2,000 in order to steal $1, which is silly. Okay, so that's the anyone can spend model. That's the one I created and the one I'll be demoing at the end of this. But there's also a prepaid model, and in the prepaid model, it's more trusted. So you get, you can have any number of people do this, but you have 20 or so people make a really big multi-sig, and they crowdfund some sats to go into it. Let's say they're like, we want to make enough blocks for this thing to last for 10 years. So they crowdfund like 3 Bitcoins or something, $60,000 should be enough to pay for fees for 10 years. And then they co-sign a linked list of blind merge mine transactions. So this part's a little confusing, and I don't know if I will be able to explain it easily. The last time I did this presentation, I think this is the worst slide. But basically, when you create transactions in Bitcoin, you don't have to immediately broadcast them. In fact, you don't even have to complete them. You can just like leave certain fields blank and still have it be a valid transaction. So the idea of the prepaid model is that you take enough Bitcoins to make a whole bunch of these things, to make a whole bunch of pre-signed transactions, but you leave the text field blank. The transaction totally valid, except someone needs to put a 32-byte string in there. You create as many of these as you need to make 10 years worth of blocks, and each one just has $1 in that transaction. It's only spending $1. But then you just create a bunch of them, and then after you've created them, these 20 people, they delete their private keys, so that list they created, those pre-signed transactions they created, are the only ones that will ever exist. As long as at least one of these people deletes their private key, you can no longer create more of these things, because you need all the private keys to create more of these addresses, you need to create more transactions. So you have a set of 10 years worth of these transactions that will create these sidechain blocks or reference these sidechain blocks. They're only missing the text field or the contents of the text field. So they can just publish all of these transactions on a website, and people can take them and fill them in as the blocks come in. As the sidechain blocks come in, you can just fill them in, pop in the sidechain blocks hash, and put it on Bitcoin. It'll still be a perfectly valid transaction. So then you just do that forever. Every 10 years, you get a new set of 20 people to make a new, another 10 years worth of transactions. And you just keep doing that over and over again forever. So this model has an expensive upfront cost. You have to crowdfund enough money to make each of these addresses and put $1 in them or so. But yeah, then you don't have the problem where you can like skip a block. There's you make enough to fund one per Bitcoin block for 10 years, and you're good. As long as Bitcoin miners aren't censoring, it'll go through. So that's the prepaid model. I don't really like the prepaid model because you have to trust 20 people, and you have to do that every 10 years. You have to pick another set of trustworthy people. But the other thing you can do to fix the problem of that comes with the non-soft fork way is you can add covenants. Covenants are a type of soft fork that allow you to specify outputs in your locking script. Which is another way of saying you can make a Bitcoin address that if you put money into it, there's like a condition that says if you spend from this address, you have to put money into this address. If you spend money from address A, you have to put money into address B. And that's a covenant. It forces you to put money into address B, otherwise the transaction is invalid. And so you can create a covenant if we had them in Bitcoin. You could create a covenant that would just loop. It would say you can take money out of address A only if you put money back into address A, and then every time you do that, you can you can force people not to steal the money. You can force people not to steal the dollar, and that helps. The reason why there's sometimes a gap with the non-soft fork model is because maybe somebody will spend a bunch of money to steal the output, and then you have to just wait a block for someone to put money back in. But if they can't, if there's a covenant on it that says you can't, the only address you can spend to is the same address, then there can't be any theft, and so you don't have any missing blocks. Any covenant can force the spender to recreate anyone can spend address output recursively, and so that prevents theft and it prevents any skipped blocks. Okay, so once again, I've said a bunch of words, and I think there might be questions. However, I'm also conscious of the time. I've still got a few slides left. So I do want to do questions right now, but I don't think I have enough time. I'm going to continue with the slideshow and then show you the demo. And then if there's time left, we'll do more questions. So what are some use cases for these things? Well, you can use them for anything you can use a sidechain for. My favorite thing to do with them is to destroy all altcoins. You could create a copy of Monero and put it on Bitcoin, or a copy of Ethereum and put it on Bitcoin, or a copy of, I don't know, Cardano, or whatever your favorite blockchain is. You can make a copy of it, put it on Bitcoin, and get rid of the altcoin. You can do all the same things, but now you're just using this, this one-way peg to put Bitcoins onto it, and there's no altcoin anymore. But this would allow Bitcoiners to use all sidechain features without needing an altcoin. Another thing you could use them for is domain name records. So this example doesn't even require you to make an altcoin. You could just have a space chain where you can add text to it, and that text could be domain names. And then that would be your registry. You would just use this blockchain as your registry. You could also do it with stablecoins and NFTs, which I don't like stablecoins or NFTs, but you could do them. You don't even, and once again, you don't need an altcoin. Well, except stablecoins are altcoins. But yeah, you could put images onto a sidechain, onto a space chain, and hash them and put them on Bitcoin. And it would be a much more efficient way to do that. So let me show you an example over here. This little block explorer is called Bitfeed, and it shows you the latest Bitcoin block. Excuse me, ordered by transaction size. So you can see this whole thing is a Bitcoin block, and most of the transactions in it are these little orange dots. They're not very big, but these really big ones, those are inscriptions. They have like a massive image file associated with them that somebody uploaded to the blockchain. And you can see how inefficient that is. Like you could pack thousands of these little tiny transactions into a block, but only a few of these inscriptions. But if we're using space chains, it becomes much more efficient. Like you could, a space chain transaction is one of these little ones. It's a tiny ordinary sized Bitcoin transaction. It's only got like an extra 32 byte string on it, and it's not even noticeable on Bitcoin. It's just this tiny little thing. But not only that, it's not only that it's so much smaller, but it can contain a whole bunch of these things. Like you could have 10 megabytes worth of NFTs on a space chain, and still the thing that goes onto Bitcoin would only be a tiny little orange dot, a tiny little transaction. So it's a way more efficient way of doing like NFTs and stuff that would allow you to have the same, security guarantees as Bitcoin, where there's not, as long as Bitcoin miners aren't censoring, you're going to have, you can come to consensus on the order of when these NFTs were created and who currently owns them, but without paying all the money to put this massive image on Bitcoin. You would just put that on the sidechain where fees are cheap and put a little tiny hash into Bitcoin. And you get the same properties. So I think a big, definitely consider, if you're into the NFT world, if you're into ordinals and playing with that stuff, that's junk. Don't even do it. Use Spacechains instead. They're way more efficient. It's going to be your company's going to have to pay a lot less in fees. Your users are going to be happier, and you're still going to get, like, you're using Bitcoin to the best and most secure blockchain to come to consensus on the order of these things and who owns what. It's a way better solution. So if anyone wants help using Spacechains to kill or to do better NFTs, hit me up. I'm happy to help you. You can also play with two-way pegs. If you've got an idea for a way to put Bitcoins onto these things and get them off, like that other guy was like, what if you lock them up for 10 years instead of destroying them? Try it, and maybe it'll work better. So the next thing I want to do is compare two-way pegs with one-way, or compare one-way pegs with two-way pegs. So there are a couple of other ways in Bitcoin that we can do side chains. And the first one over here is called a federated sidechain. So that's a blockchain that's run by a group of people who have money in an M of N multisig, meaning like a 13 of 15 or 12 of 10 or something, 10 of 12 or something like that. And we can do that today. Bitcoin's had, multisig since the beginning. We don't need any soft forks to create multisigs. But basically, to add money to this sidechain, you send it to that multisig, you send it to this group of people. They credit you with the same amount on the sidechain, or usually that part happens automatically. And then if you want to get off the sidechain, you just tell them, hey, here's my proof that I own this money on the sidechain. I'm done using it, so I want to go back into Bitcoin. And if you have like 5 Bitcoins on the sidechain, they will send you 5 Bitcoins out of their multisig. And as long as they don't steal it, that works great. I think this is a pretty awesome solution. Liquid does this, Rootstock does this, Stacks does a little bit different. But yeah, the federated sidechains work pretty well, and I think they're good. But they do have a problem, which is that you have to trust those people who are holding your money, and there's nothing stopping them from stealing it except their reputation. So yeah, that's federated. Another type of sidechain is a drive chain that's being presented right after this. A drive chain requires a soft fork to add in BIP301 and BIP300. BIP301 is a blind merge mining soft fork that lets us do it more efficiently, and you'll learn more about that. BIP300 is a two-way peg mechanism to add money and remove it from a sidechain, and that is pretty. Other than that, they're actually pretty similar to Spacechains. Like with Spacechains, you take a hash of each block and you put that hash in Bitcoin, and then but this has a way of getting money in and out, where Spacechains don't really have a good method for that. So that's BIP300 and BIP301, or also known as drive chain. You'll learn about that in a second. And then the last thing I want to talk about is a rollup. A rollup is a type of blockchain where instead of taking a hash of blocks and putting them in Bitcoin, you create a zero knowledge proof of their contents, create a zero knowledge proof of all their transactions, and then you put that on Bitcoin. And if you want to add money, so that doesn't need a soft fork. You can already create zero knowledge proofs and put them on Bitcoin because they're just text. Bitcoin has text fields. But to add money to them, you'd have to send it to a Bitcoin address that is guarded by a function that says you can only spend this money if you prove, that with zero knowledge that you own that money on the sidechain. And such a function does not currently exist in Bitcoin. So you need a soft fork to add that. To take money off of a rollup, you'd do whatever that script requires. You'd supply a proof that you're allowed to according to the rollup's rules. You'd prove it in zero knowledge, and then Bitcoin would let you take the money. So that's a way to do. That's what rollups are. They exist on other blockchains. They kind of exist on Bitcoin, but without like this part, and so they're not as good. But yeah, those are 3 alternative ways of doing sidechains. And really, the advantage of Spacechain by comparison is that there's no soft fork needed for Spacechains, and they get you all of these cool properties, except for a way to put Bitcoins on and get them off again. But yeah, so that's what Spacechains are. Here are some resources. I'm going to put a link to this presentation. So let me get the shareable link. I will put this into the chat so that anyone can review it and take a look at the references. All right, so there's that. And then lastly, I want to show you guys a demo. I want to show you a demo of how they work. So the one I'm going to show you is my Spacechain launcher, which we're about to do that Spacechain launcher. There's also one called Soma. This is the one on Signet, and it's created by a better developer than me named Fiat Jaff. So check that one out as well. Check out Soma. But here, if you all want to follow along, you guys can create a Spacechain too. And so I will send you this link. Let me go to the chat and say, make your own Spacechain here. There you go. And let's just do one together. So here we are and on the Spacechain launcher, and we're going to make a Spacechain. So let's give it a name. Let's call it the BTC Startup Lab Spacechain. And you can create a little Genesis message like, Satoshi put in the first Bitcoin block, Chancellor on brink of second bailout for banks. We'll just put BTC Startup Lab is the best. Okay, so that's going to be our Genesis message. And then it says read before clicking, but I'm going to skip that because I only have 10 minutes and this looks like it would take 30 minutes to read. So just click submit, and yep, that's the data I want to use. So here is a visualization of our block. It's only got one piece of data in it, and all we have to do is put money into this Bitcoin address, and it will automatically use that to create the thing. So I'm going to go to a testnet faucet. This is all being done on testnet. I'm going to paste the Bitcoin address, and how much sats did it want? It wants 846 sats. So 846, send. There's a motorcycle. Okay, so money should be going into this address, and as soon as it detects it, we should see a space chain created. Our own Bitcoin Startup Lab space chain. And if this isn't the easiest way to create a blockchain, I don't know what is, because all we're doing is we're just adding a piece of text to Bitcoin, and we're storing the block data, in our browser. And if any of you want to join this space chain or view this space chain or see the transactions in it or whatever, I'm going to share with you a public link, so you can do that. But let's see, I'm still waiting for this thing to get seen. Let me go check that address, see if the money's arrived yet. And it has. The money arrived, and success. The thing tells me the money arrived, your space chain block is anchored in this transaction. So let's go see it. There's our little transaction. It's in the mempool waiting to get mined. And just like I told you, it's got a little witness data in here, a 32-byte string, referencing the piece of the hash of the sidechain block. So let's hit OK, and we can view it in a little explorer. This is our sidechain network. You can view our first block. Check it out. There's its hash. There's the transactions where it's anchored into Bitcoin. It's not yet confirmed. It paid a fee of 300 sats. It's a small space chain block because it only has one thing in it, which is a short message. One transaction, that's the one that contains that message. And there it is. You can even see the transaction, creating the space chain and giving it the little message. You can also register to become a miner. Let me share this page with everyone so you can view it with me more.
If you don't mind, can you put the link to your presentation in the chat again? It didn't appear in our chat for some reason.
Oh, yeah, I don't know why it didn't, but I will. That's easy to do.
Thank you.
Share the link. Oh, that's because I am DMing someone. Link to this presentation. And then I will give you a link to the launcher. So where's the chat? Link to the space chain launcher. And then lastly is our space chain that we just created. Where? Yeah, there it is. link to our space chain. There we go. Now everyone should be able to see that. I was set up to DM somebody. I apologize for that. We can register to be a miner though. And so now we're able to mine blocks on this chain. And let's see. You can only mine one block at a time. So we have to wait for this one to confirm before we can mine another one. But yeah, this thing allows us to just add text. We can be like, you know, this is maybe this is a file. Maybe this is a giant image. And that's our transaction is just going to have a giant image to it in it. And we're just going to put that on there. We'll pretend this piece of text is, you know, a really long, you know, image, you know, X of an image or something like that. We can put in messages, you know, I love Jenny. We could put that in there. And once the first one's been mined, we can mine the second one. Of course, if we try to do it now, it'll be like, hey, you can't. You got to wait till the previous one is confirmed. But it's the same process. You spend, you know, 800 sats or so mining it, and then it's like it costs about $1, and you're good. Then you just mine it, and things are done. So anyone can mine this. Like anyone can register to be a miner. We all share blocks with each other in this sidechain network. Since this is just a proof of concept, it dies after about 500 blocks. It'll stop. You know, it'll just run out of space in your browser to store these blocks, and it won't work anymore. But as a proof of concept, this shows that you can do, you know, side chains on Bitcoin. Anyone can make them. And you also have the ability in here to like buy and sell space coins. So this part's super wonky, but you can purchase, you can burn Bitcoins on here to create space coins, and anyone can do this. And then you can sell them to people if you want to, like not for more than they costed, because then they'll just make them themselves, but you can do that. And it gives you a little wallet so you can see how many sats you have, or how many space chain sats you have, space coins. So yeah, that allows you to do a whole bunch of stuff on here, and that's basically it. I do have 5 minutes left for questions, so I'm going to go back to the chat and view those. But yeah,
I think we had a question from Alexander. He's had his hand up for a while.
Okay, go for it, Alexander.
Yes, I want to ask whether I'm correct in thinking that you cannot prevent double spending on the side chain, given the fact that Satoshi in the white paper said the only way, the way the double spending is prevented is that the miners know about all the transactions, hence why they need to run full nodes. But if you run a side chain and then you only add a header or a hash to the Bitcoin block, that means you could have double spent the coin on the side chain, and then the miner would add a valid block to the Bitcoin blockchain, but that would contain fraudulent transactions. So am I correct in thinking here, or am I missing something?
You are missing something. You can't. It's possible to include the hash of an invalid block, or the hash of a block containing fraudulent transactions. Since miners don't validate any of this stuff, they'll happily include that in Bitcoin.
Yeah.
However, that doesn't allow you to double spend, because people who are on the side chain do validate this stuff. So their own client will go through and download each block and check that there's no double spends in it. And if there are any, they'll say, oh, this block is invalid, and they'll skip it. The same thing happens in Bitcoin, actually. There have been, in Bitcoin, we download these things called block headers before we download the blockchain. And some block headers have invalid the hash they contain, the Merkle root of the Merkle tree, that Merkle tree contains invalid transactions. And when your node is synchronizing, if it finds one of those block headers, it will download the block, check for the transactions, and if it finds any double spends, it will reject that block. So space chains just do the same thing. They treat the hashes as block headers, but they're not necessarily valid. They're only valid if you check the actual block and make sure there are no double spends in it. Then if there's no double spends, then it's valid. So yeah, this doesn't allow you to do double spends.
But what consensus parameters prevent double spending on the sidechain? Because that you need a whole mechanism, right? Is it similar to Bitcoin, or is it?
It's however you design it. But yeah, the one that I made is just a copy of Bitcoin. So you just check to see if the UTXO being spent exists, and if it exists, then it's good. If it's already been spent by a previous transaction, then the UTXO doesn't exist anymore. And so then you have an invalid block and you skip that one. So
Yeah.
yeah, that you can review my code base to see how that works. I converted it into JavaScript.
Yeah.
But yeah,
It's
it
cool
does-
that you can free up the space on the main Bitcoin chain. Like you don't need to use the main Bitcoin chain to add like NFT data or whatever. You can just use this sidechain, which is cool because then yeah, it makes more sense. Yeah.
Yep. Thank you. Thank you for that question. Let's see if there's any more in let's see.
We have one more hand up from
okay.
Jay.
Hi.
Hi.
So my question would be like, I want to know this magic number 546.
Yeah.
Why the anchor fee is actually 300 and we are going to pay 8046. I think that's related, right? So what
Yeah.
was the special number?
Bitcoin addresses have a dust limit of 546, which means you cannot have less than 546 sats in a Bitcoin address. Although that's not quite true anymore because SegWit changed it, and so I'm actually overshooting because I'm using SegWit, and SegWit allows us to go slightly less than that. But anyway, I just treated the old limit as if it was still the limit of 546. So you can't have less sats than that in a Bitcoin address. Yeah, but with exceptions. But then I added 300 onto there to make it 846 because those are going to go towards fees. The 300 sats on top of the 546 are going to go toward fees. And so the 546 just keeps on going back into the address. So it always has some money in it. And then the 300 additional sats is used to pay for fees. Of course, you can just send more if you want to pay. If you want to pay a larger fee, you can just, like if fees are high, you can just pay more. So that's what that's for.
So basically we are trying to pay the gas fee to encode the data, but we need a little bit extra to keep the address still has some money.
Yeah. Oh, you could steal from it. You could just take all the money out of it. And then that would not kill the space chain. Just in the next block, the next person who wants to mine something would add more money to it so they can do that. But presumably on a space chain, you'd be earning fees by mining. Like you wouldn't be adding blocks to this thing for free. You'd be charging money for it. And then as you charge money for it, you can earn back enough to bid higher and make sure that you're always the one, or you try to always be the one to mine the next block. But
so mining,
we're past time. So I'm afraid that I have to cut off the questions here. But you can contact me on Twitter, super_testnet, or you can contact me on Telegram, super testnet, no underscore. And on Nostr, you can search for me on Nostr, just super testnet, 2 words, and ask me more questions. But thank you so much for watching my presentation. And now let's watch a much smarter man than me and the inventor of blind merge mining tell us about his solution to all this stuff, DriveChain. So thank you so much.
Fantastic. Thank you so much, Super Testnet. Let's get a group picture with you before you head off. Everybody, let's cut our videos on. Oh yeah, look at that. Everybody's looking good this Saturday. Beautiful, beautiful. All right, let's count backwards from 3 and then we'll thank Super Testnet. 3, 2, 1. Thank you,
Super Testnet. Welcome back.
Thank you.
Welcome back.
Thank you. And you're welcome. So what happens next?
Oops. Hey, Super Testnet. Great presentation.
Thank you. Glad to do it.
I got more out of it the second time. The first time was, it was like, wow. This time got more details. Super. So I actually want to ask you, what do you think should be because I dropped off for a second there. What do you think should be the first use case, or maybe like the top 3 use cases for space chains?
Well,
how would you apply it?
There are 3 space or side chains that I hear people saying they want. One of them is a privacy side chain. One of them is one that's got a very expressive scripting language like Liquids or like Ethereum's. And then one is a big block side chain where you can have like massive amounts of transactions, which should help with scaling or potentially help with scaling. Yeah, like the guy in the chat says, Monero, but with Bitcoin. I'd kind of like to do that. Although with Spacechains, it's not actually, it's like burned Bitcoin, it's destroyed Bitcoin. So it's a little different, but yeah, I would like to see those three brought on as the first three, use cases for them. And then lastly, I think they're way more efficient. I think they're way more efficient than putting all this data on Bitcoin for ordinals or in inscriptions. So putting them on a space chain instead would still get you the same ordering, the same, like you'd be using, the strongest, most secure blockchain in the world to check who issued and who owns an NFT. But you'd not have all the data on Bitcoin. So I think that would be a really good
Oh, wow.
solution for them as well.
So it's basically like the same properties, but yeah, okay. All right, I get it. It's almost like a separate database with the same properties.